All right, guys, welcome back. We are doing 2.5 today, which is proving statements about segments and angles. So if you remember to 2.4, we were talking about proofs where we used algebraic reasoning. So we had the addition property of equality, or subtraction property of equality, multiplication, division, substitution, and distributive property of equality. So today what we're going to be doing is working through proofs like we did yesterday with all of the statements on one side and reasons on the other. But instead of dealing with equality, or where we're moving things to one side of an equal sign or another, what we're going to be talking about today are properties that deal with segments and also with angles. So think about some things we've talked about with segments. We've talked about the midpoint of a segment, right? Or we've talked about an angle bisector. Both of those are where you have two equal pieces on each side, right? So we're going to kind of talk about some proofs that include some of those properties we've learned in chapter 1. So first of all, what is a proof? So that's kind of one of our goals here today. A proof is a logical argument, and it uses deductive reasoning to show that a statement is true. Remember, deductive reasoning was when we have conclusions based on facts or definitions, theorems, postulates, etc. So we're going to be using deductive reasoning, or we're going to be using the theorems we've learned in the past to prove that something is true. So let's get started on our very first proof. Just like last week, we will start off by making a T table here, and we'll have our statements on the left and our reasons on the right. You can start every single proof that way, so you don't have to wonder, how it looks. Every one of them will look just like this. Now, your proofs may have any number of steps. This one has 5, but they could have more, they could have less. So, that'll change depending on the problem. All right, so let's start off with our given. So at the very top of your question that they're asking you to prove, they will give you at least a little piece of information. So it says, given that T is the midpoint of segment SU. So on my line 1, I'm going to say T is the midpoint of segment SU. And how did I know that? Well, I knew that because it was given to me. So that is the reasoning for that. Now, if you look over on the right-hand side here, another thing that was given is this diagram. So you are able to use the given up here and any diagrams that they start you off with as part of your proof. So anything that they give you is fair game to use throughout the body of your proof. Now, eventually we want to get down to proving our very last line here. Line 5 should be proving what they're asking us to prove. So by the time we're finished, we should have at the very end of our proof, x equals 5. That should be where we stop. So let's see if we can use line 1 to get us down to line 5. So it says T is the midpoint. Now think about, what does the midpoint of something mean? The midpoint is the point in the middle, right? It's the point that breaks up something into two equal pieces. So in this case, I have a segment, and on each side of this segment has two equal pieces, right? This side over here is equal to this side over here because of the fact that this is the midpoint, okay? So if you look at our picture, T is in the middle. They told us that. And so I know that segment ST on the left there has to be the same as TU, right? How do I know that again? Because it's the midpoint, right? Okay, so we're going to put that into our proof. So line 2 is going to say, in fact, I'm going to give myself a little bit more room here. Can I do that? Oh, no, I can't. Okay. So I'm going to say line 2 is ST is equal to TU. And again, the reason I knew that ST was equal to TU is because the two segments are equal because of T being the midpoint. So that is what it means to be the midpoint. So that is the definition of midpoint. The definition of what midpoint means is what told me ST was equal to TU. Okay, well next, how big is ST? It is 7x. And TU is 3x plus 20. So how did I get from line 2 to line 3? How did I get from here to here? Well, all I did was plug in what the numbers were in the picture, right? So that is simply the substitution property of equality. All right, now that I have an equation here, I'm obviously just going to start solving this like I would in Algebra 1. So I'm going to subtract that 3x from both sides, leaving me with 4x equals 20. Now, how did I get 4x equals 20? I subtracted, right? So that is the subtraction, POE, right? Okay, we have one last step. So obviously I'm going to take that 4 over to the other side, and I'll get x equals 5. And how did I get the 4 over? I divided it, right? So that is the division, POE, property of equality. So at the very end, I should have what they asked me to prove. And that's how I'll know that I'm finished with my proof, that I've reached the last step. So sometimes they won't even be numbered for you. You'll have to number it statement 1, reason 1, statement 2, reason 2, and you won't know how many steps there are, but you will know that you have finished when your last line is the same as what they were asking you to prove. All right, let's try another one. This one's a little bit longer, and this time we're going to be talking about angles. So it says step 1, angle 1 is supplementary to angle 3. So think about what that means, supplementary. And it says angle 2 is also supplementary to angle 3. So in this case, they gave us 2 items. Now, a lot of people will put that entire statement as one line on the proof. I kind of prefer to break it up and to use that as 2 lines on my proof. So you'll see some people do, or you're given as this entire thing here. What I'm going to do is I'm going to use this as 2 separate lines on my proof, 2 givens this time. So I'm going to say angle 1 is supplementary to angle 3. And angle 2 is supplementary to angle 3. And both of these are given to us. So that is the reason for both of these. All right, now eventually our goal here is to get all the way down to the end where we can prove that one angle, or angle 1, is congruent to angle 2. So that's our final goal. It's going to take us a little, you can see it's going to take us several steps to get there. So first of all, let's start with line 1. We said angle 1 is supplementary to angle 3. So think about what that means. If something is supplementary, or if an angle is supplementary, it means that they have a total, if you add them together, a total of 180 degrees, right? So let's write that down. Angle 1 plus angle 3 is 180 degrees. Now, how did I know that? Well, I knew that because that's what it means to be supplementary, right? So that is the definition. Oops, can't spell today. Definition of what? Of supplementary. All right. Now, if you look at line 2, we had something really similar, right? We had angle 2 is supplementary to angle 3. So I'm going to do the same thing here. I have angle 2 plus angle 3 equals 180, and that is also the definition of supplementary. Now, from here, it gets a little, you kind of have to like play around. So there are some tricks you'll learn. You'll see proofs over and over again, and you'll kind of learn some of these tricks that I'm going to use. But do you notice here that we have 1 plus 3 is equal to 180. And then we have 2 plus 3 is equal to 180. So we have 2 separate lines. We have the yellow and the purple there that both equal blue. Now, if 2 different things equal blue, is it fair to say that those 2 things also equal each other? Do you see what I mean here? So if angles 1 and 3 make 180 and 2 and 3 make 180, then shouldn't 1 plus 3 equal 2 plus 3? Do you see what I mean here? Instead of saying both of them equal 180, couldn't we just say they both equal each other as well? So that's going to be my next line. Angle 1 plus angle 3 is equal to angle 2 plus angle 3. Now, you do have to come up with a reason. And so if you think back to yesterday in section 4, we talked about the symmetric property of equality, the transitive property of equality, and the reflexive property of equality. One of those is what we're looking at right here. This is the transitive property of equality. When you have two separate items that equal one thing over here, then those two separate items are also equal to each other. So that is line 5. That's the transitive property that helps me come up with angle 1 plus 3 equals angle 2 plus 3. So now I'm going to try to be a little even more creative here and figure out, eventually I need to get to this, right? I need 1 to be congruent to 2. So to get there, how about I first of all get rid of the angle 3's? So if I have angle 1 equals angle 2, how did I do that? Well, all I did was subtract angle 3 from both sides. So that is the subtraction, POE. All right. Now, is that the same thing as angle 1 congruent to angle 2? It's not. When something is equal, that is not the same thing as being congruent. So my last line is going to be me changing that to a congruency symbol. And to do that, we use what's called the congruence property, basically, or property of congruence. Either one is fine. There you go. That's it. So again, you're going to know that you're finished because your last line is the same as what you were trying to prove. Okay, now this next slide, if you want to kind of glance at this real quickly, you can. This is the same exact slide as what I showed you on 2.4, but this time, if you notice, all of them have a congruency symbol, but the properties are the same. Reflexive still means that something is congruent to itself this time. Symmetric means if two things are symmetric, you can flip them around and they're still congruent. Transitive is when you have two items equal to one common thing, then those two items are congruent, okay? And then that works for segments and also for angles. Okay, so basically this is just a review of what we talked about yesterday, using, instead of property of equality, these are properties of congruency. Instead of POE, now it's POC, but it essentially is the same properties. All right, let's look at a couple more here. So name the property that illustrates this when something is congruent to itself. That is the reflexive property of congruency. When you have PQ congruent to JG and JG equal or congruent to XY, if this is the same as this, then that is the transitive, POC. All right, next problem. Write a two-column proof for the reflexive property of angle congruence. So it says, given angle A, prove angle A is congruent to angle A. Okay. Well, if I was given angle A, I can say it's congruent to itself by the reflexive property. Simple enough. Okay, let's get into two more proofs here. Now, I really want you guys to pay attention to these because these are going to be ones that you're going to see over and over again. Hint, hint, you might see them later on. Okay, so it says ray MP bisects angle LMN. So look at the picture. We have ray MP is bisecting the larger angle there. Okay, so that means that we have this angle here congruent to this angle here, right? Because bisecting means to cut in half. Now, I'm going to go ahead and write that down as my first line. Ray MP bisects angle LMN. That's given. Now, technically, if you look at the picture, the angles are marked already, right? So technically, I could say this angle here is congruent to this angle here because it's marked in the diagram. But I'm not going to say it because it's given. I'm going to say angle NMP is equal to angle PML. And the reason I know that they're equal is because that's the definition of bisecting. Okay, that's what it means to bisect, right? Is that they are cut into two equal pieces, so they are equal. Okay, next. Now, again, kind of think about what we're trying to prove here. We want that the 2 times the measure of angle LMP is equal to the measure of angle LMN. Okay, so let's start off over here. Look at the picture. Would you agree that this blue angle plus this green angle is equal to the big angle? Would you agree? The top one plus the bottom one equals the bigger angle altogether. Okay, so let's think about that. The top angle plus the bottom angle equals the big angle. Let's write that. The top angle is angle NMP. The bottom angle is PML. And we know that that equals the big angle, the total angle, NML. Now, the reason that that equals each other is the angle addition postulate. And we actually talked about this in chapter 1, but it's been a little while. The angle addition postulate just says when you have 2 smaller angles and you add them together, you get the bigger angle. So that's what we just did there. However, we know that NMP is equal to PML. So instead of having a PML right here, I'm going to replace that with what it's equal to. It's equal to NMP. So I'm going to have angle NMP plus, and I'm going to bring that down, but instead of PML, I'm going to use NMP. So I brought this down, and then this guy kind of right here in the middle got replaced, okay? The reason it got replaced is because we knew it was equal to NMP. So essentially what we did was the substitution property. We just took what something was equal to and we plugged it in that spot. Okay. Now, if angle NMP plus angle NMP equals angle NML, would you agree that there are 2 of those now? Oops. There are 2 of them. There you go. Okay. So, oops. So essentially 2 of those top angles would be the same thing as one of the top and one of the bottom because they are congruent to each other. And that would be, you could say addition. No, you couldn't say that. What could you say here? If you combine the 2, I would just say that that is simplifying. Because if you have 2 of something and you add them together, like if you had x plus x, that would be 2x, and that's just simply combining like terms or simplifying. So it looks like I have an extra step here. I hope I didn't leave one off on accident, but it looks like I finished early. So I do have what I was trying to prove here and here does match up. So it looks like I'm good. All right, we do have one more. Sorry, this is a long video, guys. It's kind of a long lesson here because there are a lot of proofs. So if you'd like to pause the video and go ahead and try this one on your own, you can. I'm going to go ahead and fill all of this in. So if you want to pause it and give it a try and then hit play and you can check and see if you got the same thing that I did. Okay, so I went ahead and filled it in and I ended up doing 6 lines. So like I said, sometimes proofs are longer or shorter than what we think they're gonna be. Also know that some teachers will teach it a different way. So some teachers might do it in 7 steps or even 8 steps. Some might do it in 3 steps. So there are ways to kind of make them longer or shorter depending on the approach that you take. So kind of take that with a grain of salt. Some of them might look different than yours and yet you could both still be right. Okay, so the first thing I did was write down my given. M is in the middle of segment AB. That was given to me. Now, I knew because of that, that AM had to be equal to AB. So that was my line 2. I knew that those were equal because they told me that I had a midpoint, and midpoint means equal on both sides. So that's the definition of midpoint. From there, I went ahead and talked about how this first segment plus this second segment added together would give me the entire length here, right? The first piece plus the second piece does equal the entire length. And so that's right here. And that is because I added the segment together, right? And so that's just simply segment addition postulate when you add 2 segments to make a bigger segment. Okay. Next, I substituted MP in line 3 for AM. And so all I did was plug that in from line 2, right? I took something that was equal and I substituted it in. So that was my line 4. But then from there, I noticed that I had like terms. And so AM and AM, if I add them together, of course, there are 2 of them. And so that's how I got 2 AM. And that you could put combine like terms, or you could just put simplify. From there, I was trying to get AM by itself. And so to get AM by itself, I divided both sides by 2. If I divide this by 2, that's the same thing as having a 1/2 in the front. And of course, if I divide both sides by 2, that is division property. So if you look here, I have this matching up with here. It asked me to prove one and basically or the other. So it looks like I'm good to go. Now, if you wanted to prove both parts, you could do a couple of extra lines here and you could multiply both sides by 2 to get it back with the 2 in there. And then you'd have to use the symmetric property to get the AB on the right side of the equation, on the left side, I guess, technically, of your equation. So that's it for today. I know it was a long one. Thanks for sticking with me. Feel free to always pause or fast forward, do things like that to help you kind of get through the videos on your own pace. All right, guys, have an awesome day. I'll see you soon.